All right. Welcome everyone. And again, sorry about the confusion with the different meetings there. We had Tim had some things that came up that he had to take care of, and I forgot to get the login credentials for his meeting. So glad that you guys were able to get around that. Again, sorry for the inconvenience. But let's get going here and take a look at Smap3D plant design for SolidWorks. Now, my name is Michael Mooney. I'm the Technical Director for North and South America here at Smap3D. I'm located in Charlotte, North Carolina, so on the East Coast. And been with the company for over 9 years now. And so we are not a new company. We've been around for a little while. Just going to give you a little bit of background about who we are, and then we'll jump into the software itself. We've been around since 1989, formerly known as CAD Partner. In 2019, we changed our name to our most popular software, Smap3D. Same people, same everything, just we changed our name to simplify things, to make it easier to know who we are. We have 7 offices around the globe. We're headquartered in Germany. Our development department is in Prague, and I'm in the US. We also have offices in Hong Kong and Shanghai. This allows us to give you 24/5 tech support in English in all locations, and then some of our other local subsidiaries have local language support depending on what your region is. We have over 2,000 customers worldwide, which is a small number in comparison to SolidWorks, but we're a very niche market and specialized and focused in the piping side of things, in the steel. And so we are also highly recommended by SolidWorks for piping applications. Okay. We're a gold partner of SolidWorks. So out of the over 700 partners that SolidWorks has, around 40 of them are gold partners. So that's the highest level of integration with inside of SolidWorks. So yeah, most of our customers work in this engineer to order or configure to order space. Typically, working with very large assemblies is a typical plant environment. A lot of things to work with and work around. And for many years now, the big push has been working in this modular space, to where we're breaking things down into more manageable size units that they can be designed in the controlled environment of your shop, and then put onto a truck or a train and shipped out to the job site location, and then I'll plug together and build out your plant from there. Okay. Now, we have, again, most of our customers are in the space, but we also have various different levels and size customers that are happily using our software. Now, what we're going to focus on today is going to be our core offering of our plant design suite, with the P&ID, the 2D schematic of getting your process and instrumentation diagram. And then we have this as far as connected to SolidWorks. So we've written already the connection from P&ID to our piping inside of SolidWorks to do the 3D layout. And then you have an option of, for the drawings, do you want to use the SolidWorks drawings, or do you want to use our Smap3D Isometric or our isogen drawings, so that we can automatically generate the drawing spools and have a consistent style that's going to be used. It'll be easier for people to understand. A lot of times this is a requirement. So from your deliverables, and you can choose whether or not you prefer to use the standard SolidWorks drawings, or do you want to use the single line isometric or the isogen style of drawings. Now, with P&ID, it is a standalone program, meaning that you do not need any other CAD tools to use the schematic tool, the 2D side. Okay. it doesn't even have to be on the same computer as SolidWorks. It's a database-driven solution. So out of the box, we ship with Microsoft Access as far as the database format. So the reason there is that it's free. It doesn't require any other, pieces of software to make that work. However, if you prefer to use SQL or Oracle or some other database, you're more than welcome to do that. You're just going to be responsible for getting the licensing for those database solutions. We do come with an extensive library of 2D symbols adhering to the ISO, the ISA 5.1 and 5.5, which is more commonly used in North America. And then there's some other localized, kind of more specialized industries with this EN 62424, which is more of like sensors and that kind of thing. So we also have a pneumatic library and various different standardizations, right? We also have automations as far as automatically putting insulation in if you needed it, or running plausibility checks to make sure that you didn't put a DN80 valve in a DN100 pipeline. So things of that nature, being able to check to see from P&ID, did I make any mistakes? Okay. And with all the intelligence that we have inside of here, we can generate lists and reports like bills of materials, component list, valve lists, those types of things from the P&ID. We don't have to wait until we get everything done in SolidWorks to get a bill of materials. Now, the Smap3D Piping module, this requires a license of SolidWorks. Okay. Now, we don't care whether or not it's standard, professional, or premium. We work the same with all of them. Okay. So we don't use any technology from SolidWorks routing. And within inside of SolidWorks, we have a to-do list. If you wish to also use our P&ID, you can connect them so that you don't have to manually input the data twice. You can reuse that information that we put into P&ID, get a list of everything that we're working with. Also, we're able to work with pipe specifications or pipe classes within inside of Smap3D Piping. So a much more simplified approach, and the way that people typically design in a piping environment anyway, based off pipe specifications or pipe classes, some people call them. Now, we're not limited just to round pipes. If you look down here in the lower left, you'll see some air ducts or HVAC ducting that we can do. Also cable trays. So we don't care about the shape of the pipe. We can create our own custom profiles. Now we're generating native SolidWorks parts and assemblies. So you can still do all of the great things that SolidWorks can do, like interference detections, using SolidWorks drawings that you see in the middle right here, simulation, composer, working with SolidWorks PDM. We're fine with all of that just because we're creating native SolidWorks parts and assemblies. We're just expanding the capabilities of SolidWorks. And then we also have other things like putting in insulation, inserting reducers. Some people design with weld gaps so that they have exact cut links that they can send out to the shop and then just plug things together. So all of that is possible with inside of Smap3D Piping. Now there's an option for an output or a drawing option, if you wish, is the Smap3D Isometric. This is an automated tool to go in and create these single line isometric. A lot of times people call them isogen drawings. And a lot of times this is a requirement by the pipe fitters or the shop that you're working with, where they say that they have to have these drawing files in this format, right? And so we do use the isogen technology, which is the industry standard for many, many years. They've been around for about 40 years and very standardized and a common tool to use for that. We can set up our pre-designed styles or templates, if you will. And then that way we can, have a lot more control and standardization within inside of your company, so that it doesn't matter what person it is that creates the drawing. It's always going to look the same, whether or not it came from, Joe or Bob or Lisa or whomever, right? We can also choose what type of output we want this to go into, whether we want it to be a SolidWorks drawing, a DXF, a DWG, a PCF file, and an IDF file, or some of the more unique file formats outside of what you can do inside of SolidWorks. Okay. Now our libraries. Okay. We have a 2D process engineering symbol library, so the P&ID library of symbols. There's about a bit over 700 symbols in that standardized library. And then for the 3D standard parts, there's about 326,000 standard parts in our pipe fitting library. So various different standards and size ranges for pipe fittings. Okay? So elbows, T's, flanges, gaskets, reducers, pipes, all of that kind of good stuff. Now, our libraries don't include what we call standard, or not standard, but they don't include what we call supplier parts. Supplier parts would be things like valves, flow meters, pumps, those types of things, to where they're very specific about what vendor and what manufacturer you're going to be using. And so we have a library or a wizard, so that you can add your own custom components, like your supplier parts, to the library, and it will work just as if it came out of the box that way. So it's customizable. Now, some of the other offerings that we have, we'll just kind of go through this quickly, just so that you guys know what else we have to offer besides the P&ID and the piping and SolidWorks in the plant design portfolio. So a big push these days is getting away from using elbows when possible and bending the pipe. So we have bending simulation, to where we can tell whether or not the pipe can actually be bent in the real world that we designed in SolidWorks. We can visualize that bending process, see any errors. Maybe it's going to, damage the pipe. It's going to split it when it, bends it too much, or at too small of a radius. Or more commonly, maybe the pipe is going to, interfere or hit the machine or the ground whenever it goes to try to bend it, because of the angle that it's in. So it can go in and do some collision analysis between the pipe and the machine or the ground, and propose any kind of possible solutions. Okay. Another offering is our SolidSteel module, getting into working with a full-on structural steel detailing tool, so that we can do all of our bolted connections and welded connections, and automate creating of the stairs and the hand railings. Okay, so a very complex process, typically, that we can automate and do really quickly. Also getting into automating the detailed drawings of these as well, and then also being able to connect through an SDNF interface, which is kind of more of a neutral file format for the structural steel world. Okay. So we can communicate with that side of things that SolidWorks typically doesn't do out of the by themselves. And then also getting out and communicating this to your CNC machines. So we have a steel to NC module called the DSTV Assistant, so that we can export our structural steel beam information and plates and that kind of thing to an NC file that can be directly plugged into your CNC machines for cutting, sawing, coping, cutting holes, that kind of thing. So, all right. Also, from a very high level thing, we have our pipe fab analysis tool. to where we can come in here and have our pipe control or our fab control and see all of the different stages in our manufacturing process of how we get in raw materials, each stage or station that it's going to go through for manufacturing processes, and see if there's any bottlenecks or any inefficiencies that we can point out and give you a better solution for and streamline your manufacturing process. And then finally, we also have a scanning tool. If you deal with scanned data, we don't do the scanning, but once you have the scan done, we can take that data into our scan to CAD solution, and instead of trying to import a whole point cloud into SolidWorks, which generally doesn't work so well in our experiences, we can pull it into the scan to CAD and selectively tell it what's important to us, and then only import that data into SolidWorks as native SolidWorks features. So not having to deal with any tessellated data or mesh files inside of SolidWorks, and only pulling in what is important to you out of that scan data. So our process chain, getting into our modules, we also do have an electrical tool, but typically with our SolidWorks customers, we don't generally get into that because there's also the SolidWorks electrical, which has a 3D element to it where we only have the 2D side. And of course, we have our P&ID, which is our standalone modules. So these things don't require any other tools. Then we have our modules that work with inside of SolidWorks. So these require a license of SolidWorks, the steel, the piping, the bending simulation, and the ISO requires Smap3D Piping, as well as SolidWorks. And then we also have our fabrication data. So the steel to NC, the pipe fab analysis tool. So we can plan everything out. We can get our fabrication data, and we can work with inside of one PDM or PLM environment with SolidWorks PDM, and then even connecting to ERP systems to organize what information is being requested for these jobs. Now, as far as what we provide for you guys as well as the software is, of course, training. Okay. We have best practices as far as we've helped a lot of companies get up online and be much more efficient. We can review your goals and what you're doing and make sure that you implement this the right way the first time, instead of getting 6 months down the road and saying, I wish I would have done it this way, or if we would have known this, we would have maybe done it a different way. And then also project support. So we have engineers on staff inside of our company, but we also have many of our customers that are design firms using SolidWorks and Smap3D that we can introduce you to if you need help with type projects where you need some more manpower. Okay. Our training kind of breaks down to 2 days for P&ID, 2 days for piping, 1 day for isometric, and generally, depending on the modules, between 1 and 2 days for training for the Smap3D steel or the SolidSteel. Okay. And so our training offerings, generally with everything that's going on right now, most of the time things are being done remote, but we do also offer on-site custom training, or in person in a classroom kind of thing that generally works better, but it's challenging right now to meet in person. So some of our customers, Grundfos is a big customer of ours that they make pumps, but they also do fire suppression systems, sprinkler systems for kind of high-rise buildings. Geyser compressors. While they make compressors, they also do full turnkey systems for manufacturing shops of getting all of their air and different fluids compressed and available to wherever they need it for whatever operation. And then Kronos is the world's largest bottle filling manufacturer. They say that 1 in every 4 bottles in the world is filled by a Kronos machine. And then Techno Alpine, they make the snow blowing machines for ski resorts, ski slopes, that type of thing. Whenever Mother Nature is not producing enough snow for the skiers, have a solution for that. And a few others here with, Casper Schultz. They make beer brewing equipment for breweries. Primetals is in the energy sector, a subsidiary of Siemens. And then here we have kind of the contrast between very, very large plants in a large environment with Planeta up on the top, doing everything inside of SolidWorks using Smap3D, and hundreds of pipelines that they typically do in a normal job. And then you also have on the other end of the scale, IAF. They make things that have to fit into tight spaces. So like in a shipping container or a small room or something like that in a building, to where they have to make sure that all of this information or these components and their designs are going to fit in the tight space that they're confined in. All right. So there's a few other customers there, and I just wanted to maybe stop and see, were there any questions at this point in time, or are we ready to jump into the software? I'll also say that if you have questions along the way, you can type them in the chat, or we'll have time at the end to go over questions as well. And so if I can ask Jan to just try to pay attention and see if there's anything in the chat while we're going through that pops up that maybe I need to answer as we go along. Sometimes I don't see the pop-up flashing whenever I'm in the demo and working with the software. So with that, if we don't have any questions, we'll jump over and look at Smap3D with inside of SolidWorks here. All right. So here I am with inside of SolidWorks. I think it's maybe my USB here is not. Yeah, that's why my headset wasn't working. My USB port seems to have gone out. All right, so with P&ID or with Smap3D, we have a couple of new tabs over here inside of SolidWorks. So we have our Smap3D Piping tab, and we also have our P&ID to-do list. This to-do list actually shows up over here in the SolidWorks task pane as a new tab. And here we can see all of the components within inside of the P&ID. Now, I like to make the comparison. This is kind of like where you make a shopping list before you go to the grocery store so you don't forget to buy things. Well, this is exactly that shopping list that's been created from the P&ID. So when we click on things in SolidWorks, it's going to, or in the to-do list, it will highlight it in SolidWorks. So you can see where that component is. And I can also look down here in the bottom and I can see that, okay, that's a 2,000 liter vessel. This is a 5,000 liter vessel. Here I got a tube type heat exchanger. And so this is all information coming from the P&ID. Now, if I come over here and split my screens here, and maybe I'll put my P&ID on one side, we'll put my SolidWorks on the other side of my page. And if I had dual monitors, I could have one on each screen. And then when we click on it, in each environment, it will highlight in both solutions. Okay, so kind of cross highlighting in SolidWorks and in P&ID at the same time, so you can see from a 2D schematic and how they relate to the 3D virtual twin, right? And so, yeah, it makes it really easy if you weren't the one that created the P&ID, or if you weren't the one that does the 3D layout in SolidWorks. Easy to see how these two environments relate to each other. All right, so typically in a process engineering environment, your designs are started and laid out in a P&ID. So that's your controlling document. Okay. Now, our P&ID here is, again, a standalone program. Okay, so here's my P&ID. And this is a project-based system, meaning that I could have many different types of pages in a P&ID project that are all stored in one single digital file, a .pro. And so here I have a cover sheet, a table of contents. I can break things down and have different chapters like diagrams, lists, data sheets, symbol legends, right? And so these are different chapters. And then inside of there, I could put, and then sometimes this might be like building 1, building 2, or room 1, floor 2, could be phase 1 or phase 2 of a process. So depending on how many sheets that you're going to need in there, it could be that many of our customers might have hundreds of sheets in a P&ID project. So here we see our logic of how things are going to be connected and connected to what. And we talked about intelligence. What do we mean by intelligent, right? So what that means to you as a user is that if you don't know what size this pipe is, we just hover our mouse over it and we see that, oh, that's an 80 millimeter pipe. And the medium there at the bottom, the last one, is PS for pure steam. If you're not familiar with what a symbol is, you can hover your mouse over it and see that, okay, this is a column with trays. Its part number or article number is 102005. You know, various different tools that we can come in here and take a look at, right? Now, another level of intelligence would be, hey, we've run out of room here on this page, and I need to continue on to another one. Well, is that going to be page number 2, or is it going to be page number 32, right? So we can have as many pages in a project as we like. But being able to map and remember what page a pipeline goes from one page to another can be a challenging thing. And so we have these hyperlinks here that we can come in and we can see that this is going to be page 2, column 8, row A. And if you look up here at the top, you'll see that, or in this corner, you'll see the gridding of the numerical columns and the alpha rows. So that's one thing, but you can actually just double click on this and we'll go and take and put your mouse cursor on where that particular pipeline either came from or where it goes to. Same kind of thing if I look over here to this side, we'll see that this runs out of room. Where does it go? Double click, and then it goes and zooms in, put your mouse cursor on where that pipeline continues on to. So very, very neat tool to be able to track of where things go and what connects to what. Now, being able to come in and do more designs and how do we actually draw things. So depends on how you get information in. We can do it either conceptual, to where we just put generic symbols in there to say that, hey, this is going to be a pump and it's going to be connected with a pipeline, but I have no idea what size this pump is or what size the pipeline is yet because we haven't done the engineering. So we can come in and we can just place any type of general pump in here that we want, and we can come in and control the size, the rotation, that type of thing. A typical Windows environment. Toolbars, drop-down menus, that type of thing. And if I go ahead and place this in here, I can say that, hey, this is going to be my P2002. This is going to be a piece of main equipment, but I don't know what size, what part number, what manufacturer of the pump it's going to be yet. But I want to make sure, has this tag number been used before? Okay. And so I hit my question mark here and ask that question, and it changes from 2002 to 2004 because 2 and 4 2 and 3 have already been used. So the next available tag number is P2004. Just making sure that we don't duplicate tag numbers. We can also come in here and put information in about, what type of fluid medium am I working with? What's the temperature and the pressures that we're going to be working with? So all of this information can be put in there. And then this would be an example of a dumb symbol. And then later on, we can come back and go into the database and connect it to a specific part number of a pump or compressor or whatever it might be. Okay. Now, we can also go the other way. Sometimes we know what part number it's going to be. And so if you have that information ahead of time, you can go right to the component database, and you can go in and we can say that I'm looking for a pump, but I don't know the part number of the pump or the article number. So we could come in and say I'm looking for something that's labeled as a pump. Okay. And so here we can see that we got a few different offerings here. I got 2 different pumps here, 3 different pumps. And so we could choose from that. We could do other queries. So if you didn't know any one of these 3, we could search by any database information. So maybe I'm looking for who's the manufacturer of this pump. Maybe we want to use a Grundfos pump. So we'll type in G, R, and it starts filtering out everything that doesn't start with the manufacturer of GR. And then we can see here that I got a couple of different pumps here and a motor. I'm going to go with this smaller pump instead of this larger one. This will fit my needs just fine, and it is of this size, but we can come in here and we can see all of the information about this particular pump, right? And so these are the fields in the database that are customizable. So we can come in here and change this from whatever the information would be, but we can add and remove data fields to meet your company's needs and provide all of that. So we'll say okay to that. And then it goes and grabs the correct symbol that's supposed to be used for that pump. So I don't even have to search through all of the library of symbols and that type of thing. And we can give this a tag number of maybe P3000. Hit my question mark to ask the question, has this been used? No, it hasn't because it didn't change. Okay. I can tell it that this is going to be a piece of main equipment, just an option. And then I can come in here and say that this is going to be hot water. Maybe it's going to be at 90 degrees C. It's designed for, 100, but I want to make sure it doesn't go over 105. And it's going to be at pressure, operating at 10 bars, maximum of 16 bars, pressure, that type of thing. And these data fields are customizable. So this is just more process-specific information. Okay, so things that might be different for each use case. And we'll go ahead and we'll point out that, hey, at my company, we don't manufacture pumps or valves and that kind of thing. We purchase them and we put them into our design. So we can actually, from the database, we can actually link this, and we see we got a picture of what it looks like, but we can actually link this to the manufacturing spec sheet of this, so that we have all the information about this pump, from Grundfos, the sizes, the flow curves, all that kind of good information right there at the engineer's fingertips. They don't have to go in and even do a web search for this kind of information. It's just right there available to you. So this is some of the powers and advantages of working with a database. And so there we have our symbol. Again, we didn't have to go into the full symbol library and look at all of these, hundreds of symbols that we have inside of here and try to find the symbol you're looking for. The database is going to tell you already what part number or what symbol that part number is supposed to be using. Now, let me turn off this little warning that I haven't saved. And See these little red diamond shapes? These are connection points. Okay, and so if we want to draw a pipeline here, we can just come out and we can pick what color line we want to use, that type of thing. And of course, we have all different line styles that you can use. Colors, line thicknesses, do you want arrows or not? So you can configure these the way that you want and save them into your toolbar buttons here so that you don't have to go in and push a bunch of buttons every time you want to draw a line. Okay. Now, we are a schematic capture tool from the ground up. So we're not an architectural CAD tool that then we've added a library of symbols or a library of blocks and call it a P&ID. We are P&ID from the ground up. So if I try to draw a pipeline that doesn't connect to something, the system's going to warn me and say, well, that's not normal. You typically have pipes connected to something. And even if you get on here that's not a nozzle, okay, or a connection point, it will flag you and ask you, hey, did you really want to do that? If so, you can park it out there in empty space. But I kind of made the mistake on purpose just to show the functionality. And the nice thing is once it gets connected, you can move it around, make room for other things, and the lines stay connected. You don't have to redraw or extend or trim or anything like that. Now, we got our pipeline connected to our pump here. We might need to tell it what type of pipe we're working with. So here we'll double click and we can give this a tag number. Well, maybe I'm new to the company and I don't remember what tag numbers should be used for this type of pipe, and I don't know what's already been used in the whole design anyway. So we can get a list here. So here's all the tag numbers of pipelines that have been used. If we were to pick one that's already been used, we could then roll up to a different available number, or we can give it a whole new numbering sequence. Okay. Or we can pick things from a list, and we can say that, oh, okay, well, things that are having acid typically start with a 300, or steam is going to be a 500, and we can come in and roll with that. And we can say, oh, well, let's do this PL 500. Has that been used before? Nope, it's available in this project. And then we can get in here for the size information. This we don't have to manually put in. We can pull from our list of pipe specifications. Some people call them pipe classes. Then we can come in and we can choose from the different sizes. Depending on the spec, we might have different sizes available, whether or not we want it to be bent piping, copper, PVC, okay, various different ones here. Get into sanitary tubing, okay, Victolic. I'm going to go with my spec 10CA here, and we're going to go a DN100 for our pipe size. And so then it writes all that information in here for me. And this is also the same pipe spec that is going to be used by the 3D module as well. So when we get over into SolidWorks. Now, what about my line information here? What type of fluid medium am I working with here? HW for hot water. Again, if I want to put that information in here, I can do that. Okay. And maybe this was going to be operating at 12 or 10 and going to 12. Insulation, do we have these types of things? Is there a certain service this is going to be? Yeah, and this is customizable as well. Now when we do this, it creates a nice label here for me. I could say, well, I'd rather have that label up here so I can just anchor the text up there, and now it is still maintained. Whether or not you want to have insulation on your pipes or not, you can right click and say with insulation, or you can right click and say without insulation, however you want it to be. But the main thing here is we have that control. And now that we have a pipe spec, so pipe specs are very powerful, and they do more than just allow you to pick the size of pipe you're wanting to work with from a drop-down menu. They can also help assist you with knowing what types of equipment you're allowed to place into this kind of pipe. And so if we look at it from here, instead of going to to the component database and I need to put a valve in here, I could pick any valve that I want or any piece of component out of here, and nothing's going to prevent me from doing it if it's wrong, right? But from your pipe spec, this is going to be designed by you to where you can tell it, oh, when we're using this pipe spec, these are the types of valves or flanges or gaskets that we need to be using, so we can place from specification, and then it will give us a list here of the approved types of equipment that I can put into this size and specification of pipe. So this globe valve right here will fit my needs perfectly. It's already, filtered out to the correct sizes and that kind of thing. And so we can double click. Again, it goes and grabs the symbol for us. And then I can just place this right into my pipeline. And we can say that this is going to be a V 3000 or V3000 for my pump. And if I wanted to put any process specific information in here, I could do that as well. Again, if I want to see the spec sheet from the manufacturer, pull that up. Boom, there's all my valves from Armaturin, my Stobu valves, and all of the details about it. Okay. So we'll say okay to that, and then notice it also rotated in the symbol into position there. It was sideways, and then I can move this down onto this nozzle if I wish to maybe eliminate that piece of pipe there. Everything looks good here. We can come over and look at some of these reports, because now if I hover my mouse over it, I'll see all of this detailed information about the pipe, about the instruments, okay, all of that good stuff. Also, we can generate bills of materials. Okay. So if I come in here and I look at my bill of materials here, and I also have component lists. So a bill of material is organized by a single line item for each article number, and then a quantity of how many. Then you also have component lists, which is going to be a single line item for each tag number. Okay, so every component is going to be identified. And then we have a article number over here. And so you might see article numbers used more than once because they have different tag numbers. So this is a more detailed list that's very common for process engineering. And so we can see all of this. If we ever wanted to find out, hey, where's this V2009? You can just double click on that, and it will go and take and put your mouse cursor on where that part is in the diagram. Okay. So it makes it really easy to find things. These lists and reports, we can come in and update them. Okay. Update all my lists. Okay. Saying, oh, there's new information. And by the way, all of the parts that you've now added on here, they don't fit onto one page. So yeah, let's go ahead and add multiple pages. And so now we'll see that it fills all the way out. I got my P3000 pump, and I also have the motor that comes along with it. Because it's a different part number, the system's smart enough to separate those out into different line items on the bill of materials or the component list. Okay, so we got all of these in here. Another type of report that can be created here is a data sheet. So for every pressure vessel that I have, I want this form filled out automatically by the software. And so we'll see the different part numbers, the different pressures and volumes inside of here. Also, if you have a picture identified with it, it will show up here as well. Okay. And so yeah, you can customize these reports and have them contain whatever you like. And then also from a reporting aspect, we can generate or auto-generate these symbol legends. And so this is going to generate these symbol legends for you automatically for each project. And it will only show what symbols have been used in this particular project. So if somebody does need to refer to the symbol legend, it's going to make it a lot easier for them to find what they're looking for instead of having to look through, a bunch of different symbols that aren't even used in this particular drawing. Okay. Now, all of this is great, but what if we need to communicate this information with other people that don't have a license of Smap3D P&ID? Now, we do have a free viewer so that people can open and view and print the native .pro file format for P&ID. But we can also export out to a DWG or a DXF. Okay. And that note, we can also import a DWG or a DXF. If we wanted to import existing symbols from another program instead of redrawing custom symbols inside of here, or if you had a layout that you wanted to pull in, that's possible. But a better communication tool is going to be a PDF, because a DWG and DXF still requires a specialized program to read them. And maybe that specialized program is something as simple as eDrawings. But also they're not secure. People could change them if they had AutoCAD or DraftSight or just pull them into SolidWorks. You could make changes. So your PDF, many good things about that. Anybody with Windows can read a PDF. They don't need a specialized software, and they can view or print only. They can't change things in a PDF. So we can choose what pages we want to include. Do we just want the diagram pages? Do we want all pages? And then do we want to include that intelligent pop-up data, okay, from the symbols and from the lines? If so, we can turn it on. If you don't want that to happen, you can turn it off, of course. We can control our file size or our resolution. And then of that pop-up information, do you want to share all of it? Or are there certain pieces of information that might be, things that you don't want to get outside of your company? And so you can come in here and turn that off. Okay. And so we can even come in and set up, various kind of presets, if you will. Right. So maybe I want, all of that information turned off. And maybe the service is fine. You can set these presets to where you can have, an internal or an external facing document, or whatever you want to name them. So if it's internal or external, turn all these things off. If it's internal, turn everything on. And then when we say, okay, I forgot to update all my lists. So we'll say, yeah, let's update my lists before we create the PDF, make sure everything's up to date. And then we can come in here and we can see that I have a 17-page PDF. I'm using Adobe Acrobat Reader DC, the free version, the free viewer that you can, free reader that you can download. And so we have all of the color, but we also have that intelligent data. Okay, what size is this? What is this little symbol? Oh, that's a diaphragm valve. Where does this go? Well, this goes to this page right here. There's my pump with all of its pressures and temperatures, again, visible from the PDF. So it's a great collaboration tool to share with your customers, with your vendors, with whomever you need to, either internally or externally. Okay, you have your reports. And not having to buy any extra licenses of the software, right? So yeah, you want to know where's my my BV210. Okay, here it is. Boom. Easy to find right in a PDF. Okay. Now, any questions so far with P&ID? Okay, before we jump over into the 3D side of things. I just wanted to pause and give you guys an opportunity to ask questions right now while they're fresh on your brain, if you had any questions on the 2D P&ID side of things.
No question at the moment.
Okay, good. All right, then let's go ahead and let's see, well, how do we get this information over into 3D into SolidWorks to do that side of things. Because right now, we don't know how long this piece of pipe is. We don't know if there's only one elbow or if there's 25 elbows that it takes to get in to work around the other things, and how many flanges and fittings are going to be necessary and that type of thing. So again, just a schematic, we can get the equipment, but we don't have, length information and that kind of stuff of how much pipe we need. For that, we need to do it in the 3D. So we can jump back over here into SolidWorks, okay? Or you could check in your P&ID into your SolidWorks PDM, and if you have workflows set up, it could notify the other person that does the 3D work in SolidWorks, or maybe that's also you. You have to do both disciplines in your company. And so, yeah, a lot of different workflows that could happen there. Our P&ID is a different file format, but all you need to do is just create a data card in SolidWorks PDM, and then you can check things in as far as the P&IDs into SolidWorks PDM. All right, so I'm going to go ahead and refresh or resynchronize my P&ID with my 3D model. Okay, we see a little progress bar down here at the bottom, and we'll see that we got some things that are out of date here. Okay, so we have our update information in CAD here. Okay, so now we know all of the new details about this particular pressure indicator, okay, which is right here, highlighted in green. And then we also have some new symbols or different colored symbols than we had before. So we got 2 orange items in here. So this is the pump that we can see right here, all of that data. And we also have the valve. So this is looking at everything from just the components. Okay? We can also change our view to look at it from a pipeline perspective. Okay? And so we can see what's inside of each pipeline. Oh, there's a valve. There's the heat exchanger. Okay? And we can also notice that here in my PL500, I have the heat exchanger and the pump. They both have blue dots on them. What the blue dot means is over here in P&ID, we said that, oh, this is going to be main equipment, so I'm going to uncheck this inner equipment box, meaning that it's not a piece of inline equipment. It's something that the pipes connect to. So that puts a blue dot on it over here, and that lets me know that, hey, my components up here with blue dots on them, I need to place those into my assembly first because pipe connects to them, and it's going to be really difficult for me to connect a pipeline to something that doesn't exist. So we'll start with our pump here, and we can right-click on this, and we can tell it to place the 3D model into CAD. So it goes and it looks at the information, and it says that, hey, there is no information here about that. Let me open up my part finder here. Okay, and so this first method is where we just downloaded something from the internet, and we haven't, customized it into our pipe spec yet. Now, when it comes time to the valve, I'll show you that more automated way, but this is the more flexible way to where you can pick whatever 3D model you want to associate to this P3000 pump. Okay, and so out of my standard parts library, okay, these are some custom parts that we've added in here, or supplier parts we call them often. I can come in and grab my centrifugal pump, and then it will load this up into SolidWorks here for me with the SolidWorks insert component command, something that everybody's familiar with if you're using SolidWorks. And this has a mate reference in it so that I can just place it right into position real quick. Or you can use your standard traditional mates to do all of that. Now this is green, checked off that, oh, now I know what that is. And then if we were to click on that, we'll see that it highlights the whole assembly here. Now we do have the capabilities, if we want to get into this very granular level, to separate the other components. And I can say that, oh, this is going to be my pump. Okay. that I have here, and then this is going to be the entire assembly. Okay. So we can control that if you want to have that level of detail. Okay. Now for the rest of this, I'm going to switch over here to my pipeline view here. And all I'm doing is just switching the order instead of having to scroll down to the very bottom. I can just switch the order of the layout here in my to-do list. And we have our pipeline 500 here. Okay. Now, there's a lot of empty nozzles that could be used here. So how do I know which one to draw and connect to? So I can right-click on my pipeline from the to-do list, and I can tell it to show me the from to points here. And it will go in and put red balloons on the nozzles that are supposed to be used by this particular pipeline, PL500. So I know that now I need to go from this nozzle on the pump to this nozzle on the heat exchanger. Okay. So now that we know that, I can hide these signal points, get them out of my way, and then I can create a new route. Okay. Now that I know where I'm going, we're ready to create a route. Now SolidWorks is going, or Smap is going to help me organize my SolidWorks tree. And so you'll see that I have all of my different pipe spools or pipelines in their own subassembly. Okay. And so Smap will help you with that. Say that, yeah, I want to create a new subassembly here for this pipeline. And so it's going to go in and create a new subassembly, and it's going to name that subassembly to match the tag number from P&ID. Okay. So maintaining that integration. And in here we've gone in and automatically started a new sketch. We've edited my 3D assembly, started a new 3D sketch. And now we can just come in and draw how we want to get from point A to point B. So I like to right click and do either a manual route or an auto route. Now, most of the time I use a manual route so that I have full control over when I want to go up, down, left, or right, and how far I want to go in what direction. But we also have this auto route tool that we could use. And what that will do is it'll allow me to just pick that I want to go from this nozzle here, and I want to go down and connect to this nozzle here on the pump. Okay. Now, we don't have a whole lot of control over this. I can tell it that I want it to be closer to the heat exchanger or closer to the pump. Okay. I can tell it that I want it to go down first before it goes over. So I could do that. Or I could tell it that, it can go on an angle instead of everything being along the X, Y, and Z. And if we want more control than that, then we're going to need to go to the manual route. But this works out good for this situation. I get a preview of the size of the pipe and what it's going to look like, make sure that I don't have any interferences. If we wanted to, we could make this a little bit closer. Okay, just eyeball it, or you can come in and put in a dimension, right? You can just use your regular old dimension tool to do that. Put a dimension in there so that this doesn't move, but I can also leave it underdefined. Say that, yeah, I'm happy with this. Let me close my sketch. And at this point in time, it's going to import the information from P&ID about the spec, the size, all the components that are in there, and now it's going to start building the assembly. Now, I forgot to point out here, but you can see that this was an empty assembly. The only thing that it had in there was a piping 3D sketch or the 3D sketch. But there was no mates, and so now it's actually building the SolidWorks assembly for you and creating all of the mates for this piping. And so here we can see we got our pipes. We have, if we look at the SolidWorks feature tree now we have all of these parts that have been inserted by Smap3D Piping. Okay, so we can see our flanges, our gaskets, our pieces of pipe. All of this great information is here, along with all of the mates. Now these are just regular SolidWorks mates. And so the point of all of this is that these are just native SolidWorks features as well. There's no proprietary special features that are being done by Smap. So the reason that's important is you can take your design that I have right here and you can share this with anybody else in your company or outside of your company that has SolidWorks, and they'll open it up and they'll see exactly what I have on the screen here. They just won't have this to-do list or this piping tree over here, but they'll see the assembly, they'll see the parts. They just can't make changes to it because for that they need a license of Smap3D. Okay. But to work around with your design, your piping, and to make sure that they don't interfere with it, yeah, it's there and it's easy. So also, if I look at this, we'll see that my pipelines here, I've chosen to design with weld gaps. Okay, some companies design with weld gaps. Other companies say, nah, we leave that up to the shop to figure out weld gaps. We'll let them do all of that. And then from here, we have all of our weld gaps, our pieces of pipe. It knows from the pipe spec that this is a short radius elbow instead of a long radius or a 5D or an 8D radius elbow. It also knew that I needed to be using welding neck flanges here instead of a slip-on flange. And per my pipe spec and per the information about this heat exchanger, it knows that I need a 1.5 millimeter PTFE gasket inserted right inside of there as well. So with all that information about the types of fittings that are being used, the weld gaps, the thickness of the gaskets that are being used inside of there, this is how we're able to create extremely accurate cut links in our bill of materials. Now we just have to go ahead and finish this off as far as putting in our valve. Now from the P&ID, it indicates that the valve should be up here on this nozzle. Okay. Now we look at this here in the virtual environment here, and we can see that, oh, if this valve is up here on this nozzle, then somebody has to climb up this ladder, climb over these pipes that are hot, and risk burning themselves or falling off the top here to turn off this valve. And so it's kind of up to you. Do I want to put it down here on this nozzle? Do I want to put it right here in this vertical section? Where do I want to put that valve? All right. And so you can choose. I'll go ahead and put it up here on this nozzle as well. But we can put it anywhere that we want as long as it's in this pipeline. If I try to put it in a different pipeline, then it won't let me do it because it's going to say it's the wrong environment, right? But I'll go ahead and I'll put it up here. So to put it on this nozzle, I need to delete the flange. And now this is the more automated method, because remember, whenever I placed this into P&ID, I didn't manually place it. I right-clicked and I placed from specification. And so now that I do that, and since it's part of my pipe spec, I can place the 3D model into CAD. And this time, instead of opening up my library, it goes ahead and it launches the insert component command loaded up with the correct valve for this particular part number. Okay, so there's my part number. It knew all of that. And so now we can come in here and it has a mate reference in there so that it knows how it's generally, mated into position. I can say that, hey, this is going to go up here on the top. This looks good there. And we have some other tools inside of here. I can come in and actually move this over a little bit here. And we have another tool inside of here that I can just say that I'm happy with all of that. My component is now assigned. It's all checked off, and everything's happy. And so what I can do is I can run a design check, and I can say, hey, is everything going in the correct direction? Okay. And we'll see that there's a component in PL500 that's going the wrong way. Will show me the details. Oh, it's the globe valve. Okay. Yeah, I wasn't paying attention, and yeah, it's going the wrong direction. Okay. And so for that, all we need to do is click on the item, which will highlight it in the piping tree over here. So we got a new tab up here where I have my piping tree, and I've chose to split my feature manager so that I can have my SolidWorks feature tree down here at the bottom. So I don't have to keep flipping back and forth between different tabs. And then we can come in and we can tell it that we want to flip the component, go the other direction. Okay. We can run our design check now. Everything's good. We can get out of here, and then we can finish placing our valve into position here with just SolidWorks mates. So we'll create a mate between this face here and my gasket there. Okay. So now all this can do is rotate. Maybe I don't want it to rotate, so I can create a mate and align that so that it doesn't rotate out of position. And then I'm happy. Okay. This is all good, but I need to right click and recalculate, or I can come up here to my toolbar buttons. Okay. And then it goes through and it will trim up my piece of pipe, and then it's going to realize, oh, there's supposed to be a flange and a gasket on the other side of this valve. And it will trim that pipe back to accommodate a welding neck flange and the appropriate weld gap based on the information in my pipe specification. Okay. And so, yeah, now everything is good here. We can, got everything checked off in my pipelines. So I'm happy. If I wanted to, I could come in here and tell it that I want to generate my insulation. Okay. So we can right click, go into my insulation, generate, or I also have it up here on my piping toolbar. It's in here as well, generate insulation. And then we can tell it, do we want it to do along the entire pipeline, or do I want to do it maybe between certain segments so that I can control the start and the end? And so maybe I want this to be a 40 millimeter offset here to give some room for my bolts. And so it'll generate the insulation here for me. Okay. That's all good. We're happy. And from there, we can actually go in and we'll just refresh or rebuild. And we have everything from the top level assembly. We can get down into, saving all of this information, that kind of good stuff. But now, how do we want to generate our pipe spools? Okay, and these insulation can be controlled with some color. Okay, I got these over here transparent. I've got this one is more of a protective insulation that has a hard shell outside of it instead of this foam. But yeah, you can control all of that. And then if you want to create your manufacturing drawings, you can of course go to your SolidWorks drawings. Okay, and so since I've created this in its own subassembly, like all of my other pipe spools here, we can actually come in and open this up in its own window and say, hey, now you can do anything else that you want to it here. And we can turn off those planes. But yeah, now you have your pipeline. You can go through and generate your drawings like you always would, or you can generate your isometric drawings. Now with the ISO, all we got to do is come in here and click two buttons, one to start ISO, one to hit finish, and it will go in and will take and generate a single line isometric drawing here for you. Put in all of the dimensions, generate your cut lists, your bill of materials, put in all of your elevations and that kind of thing. So everything that you're going to need for manufacturing. You can customize these to meet your needs of what your shop requirements are or whatever. And so it's going to create a DWG and a PDF. Okay, a lot of times PDF is the deliverable that people need to use. Okay, it's secure, don't have to worry about readers and viewers and software, that kind of thing. So we know that we need 3.9 linear meters of 100 millimeter pipe. Got my elbows, my flanges, so I have my fabrication list. Then when it comes time to erect this into the field, I know that I'm going to need gaskets, and I also know that I need 48 washers and 24 nuts and bolts. Okay. Now, if I think back to this, I did not put nuts and bolts and washers in my assembly, but the system is intelligent enough to know that based on the types of fittings that I used here, I'm going to need these components to be placed into my building list, right? To make sure that they get ordered, get sent out to the job site. And I can also see each individual piece of pipe, the length of that piece of pipe, the end preparations. This is butt welded, so it's going to be beveled on each end, but it could be threaded, could be socket welded, could be Victaulic, whatever end preparations are going to need for that kind of pipe. Okay. I have information about the pipe spec, okay, who created it, and then I also have this information out here that's elevations. Okay, so I have the elevation, the northing and easting of the direction there, the dimensions, so you can control how you want to dimension them. Do you want to dimension the overall lengths? Do you want to dimension the center lines? Do you want to dimension the welds? So this can all be incorporated. Okay. Then we have the elevation of the other connection up here at the top, 3.1 meters. But then notice over here for my valve, I actually have the tag number that I put into the P&ID has gone all the way into SolidWorks and come through out to the ISO drawing. And then I have my stack here of my 4, 5, and 6, and 7. So we'll see that, oh, my 4, 6, 7, and 5, right? Yeah. And so now we have our nice manufacturing drawing here, ready to be sent out for review or for fabrication. Okay. Of course, also you have the DWG. The advantage there is it's a DWG, so if you wanted to go in and put other notes in there, you wanted to make a change to it, you could. But typically, I don't like to create extra work for myself, so if I can just get my settings correct inside, I don't have to touch it. And if I would have done this from the top level assembly, I did this while still working in the subassembly here. But if I would have run this from my top level assembly, it would have batch generated every pipe spool in this this design. And I ran that earlier because it takes about four, almost 5 minutes to do this. But now I got 67 drawings here done with all of the different formats and reports to where I could have all of the components or the material list, but different styles of drawings. So if I went in here and looked at maybe my my 240, okay. So here we have a different style of drawing, a spool, where it's automatically broken out flange to flange and more detailed dimensions. Okay. But then this also has a weld list and a cutting list and one single bill of materials. It really depends on how you want to show things. If I look at this same drawing up here with the weld box, we can see that, oh, okay, I can see what it connects to. Okay. And again, different dimensioning styles, but you have control over that, and you can set these things up to be the way that you want. A more detailed welding list, so you can get into shop welds, field welds, what size they are, and all of those different aspects. Okay. Yeah. And we've already seen our cutting list. Okay. And yeah, and so that's really our process of going from P&ID all the way into SolidWorks. Okay, doing the 3D layout in SolidWorks, and then being able to choose whether or not we want to use SolidWorks drawings because they're easier for non-pipe fitters to read, or is our audience the pipe fitters and they're requiring these isogen drawings, which are much faster to generate instead of having to manually do everything in SolidWorks. Also, SolidWorks doesn't create these kind of things. You would have to manually draw them as sketch lines, or the same way that you would do in DraftSite, for example, where you just have to manually draw all these things, have blocks for some of this stuff. But yeah, bit of a lot of work. So here it takes us about 10, 20 seconds to generate these drawings automatically. All right. And so, yeah, we have some customers that say, yeah, it takes, 15, 20 minutes to run it, but then I have 200 drawings done, and I'm okay if it takes 15 minutes to do 200 drawings. Typically, it takes me about an hour to do each one, so I'm okay with that. And that's really our process workflow.